We're surrounded by it, we seek it out, but do we ever really stop and think about what makes a space silent? Today, we're pulling back the curtain on the hidden science behind quiet. Let's dive in.
Think about it. Have you ever walked into a library and just felt that instant sense of calm? Or, on the flip side, been in a restaurant where you can barely hear yourself think? That feeling, that huge difference in sound, is exactly what we're going to explore.
And here's the big secret. The quiet you experience in those really well-designed spaces, well, it's almost never an accident. It's the result of some very careful, very intentional, and often totally invisible engineering. Now, to really appreciate the solution, we first have to understand the problem. And noise, it's a much bigger deal than most of us realize. It's not just something that's annoying, it has real-world consequences.
So, what is noise, technically speaking? It's actually super simple. It's any sound that is unwanted. That's it. Could be the hum of your laptop, the rumble of an air conditioner, or a conversation from the next room. If you don't want to hear it, it's noise.
And this is where it gets serious. The effects of all that noise are way more than just being distracted. We're talking about the risk of permanent hearing loss, increased strain on your heart and circulatory system. It can genuinely drag down your overall well-being. This isn't just about comfort. Controlling noise is a critical health and safety issue.
Okay, so if we want to stop noise, we first have to understand how it gets from point A to point B. Let's follow its path.
In acoustics, pretty much every noise problem is broken down into these three elements. You have the source, like the big fan in an AC unit. You have the receiver, which is you, the person in the room. And connecting them both is the path, the way the sound travels. To solve the problem, you have to interrupt one of those three things.
And this is a brilliant way to put it, because it highlights one of the biggest challenges in modern buildings. The very same ducts that deliver fresh air to every room can also act as perfect conduits for sound. They're literally sound superhighways that carry noise from a central fan right to your desk.
Now, here's a quick but really crucial distinction. Let's think of a light bulb. It has a fixed wattage, right? That's its raw energy output. That's kind of like sound power. But how bright that bulb seems to you, well, that depends on how far away you are, if there's a lampshade on it, and so on. That's sound pressure. It's what you actually perceive. The whole game of noise control is to lower that perceived sound pressure right where you're sitting.
So if you can't always change the noise source, and you definitely can't get rid of the receiver, the person in the room, what's left to control? The path. And this brings us to the hero of our story, the sound attenuator.
Its job is simple in theory, but pretty complex in how it works. An attenuator, sometimes called a silencer, is a device specifically engineered to be installed inside that sound superhighway, the ductwork, to reduce the noise that's traveling through it.
Honestly, the best way to think about it is as an acoustic roadblock. It's purpose-built to create a really challenging path for sound waves, forcing them to get absorbed and trapped. But, and this is the clever part, it's also designed to let the air continue to flow through with minimal resistance.
So what's actually inside one of these? It's a pretty neat piece of engineering. You had these carefully shaped splitters designed to let air flow through smoothly. But inside them is this special acoustic material that basically acts like a sponge for sound waves. The whole thing is sealed in an airtight case to stop sound from leaking out, and then it's all rigorously tested and certified to prove that it actually works.
Of course, noise control isn't a one-size-fits-all problem. The noise from a giant fan in a factory is totally different from the sound of a private conversation you don't want leaking out of a boardroom. So you need different tools for different jobs.
The most common types you'll ever find are these guys, rectangular and circular attenuators. They're the workhorses designed to handle the everyday hum and rumble of fans and airflow in the HVAC systems of most offices, schools, and buildings you go into.
But here's a much more specific and probably more relatable problem. What happens when two private offices are connected by this same little piece of ductwork for air circulation? How do you stop a private conversation from traveling right through the vent and into the next room?
This is where a specialized tool comes in, the crosstalk attenuator. Its entire purpose is to stop what engineers call crosstalk, which is really just the transfer of noise, and especially speech, between two connected rooms.
And you can immediately see how critical this is. Think about private offices, boardrooms where sensitive deals are being discussed, or even hospital patient rooms where privacy is absolutely non-negotiable. In any of these spaces, ensuring speech privacy is just as important as ensuring good air quality.
So this brings us to the final piece of the puzzle. We have the problem, and we have the tools.
How do engineers actually put it all together to create that perfectly quiet space?
How do they decide what level of quiet is quiet enough? I mean, do a library and a workshop need the same acoustic treatment? Of course not. So, how do they make that choice?
They use established standards, like the noise criteria or NR scale you see here. A lower number means a quieter space is needed. So if a recording studio needs to be incredibly quiet, down at an NR of 20. But in a workshop, a much higher level of background noise, maybe up to 55, is perfectly acceptable. Engineers use these specific targets to choose the exact attenuator needed to hit the perfect level of quiet for any given room.
And that's really the crucial takeaway here. That sense of peace in a library, the ability to focus in a private office, or the privacy of a conversation in a hospital room. It's not magic, and it's not an accident. It is the direct result of engineers understanding the source, the path, and the receiver, and then intentionally designing a system to control the sound.
So the next time you step into a space that feels remarkably peacefully quiet, take a moment. Listen to the silence and ask yourself, what other invisible systems are working all around me right now, shaping my world in ways I've never even noticed?